Hi, welcome to Chapter 9. This is the Section 9.1 Notes on Translations. Again, the whole chapter is on transformations, which just basically means a change. We're taking shapes and we are changing them, often to a new location. Sometimes they're changing size, but sometimes they're always staying the same shape. And often they're staying the same shape and the same size, just moving to a new location. So you probably have done some of these transformations in the past. You may have called them something different. Instead of a translation, you might have called it a slide. Instead of a reflection, you might have called it a flip. And instead of a rotation, you may have called it a turn. But it's the same type thing here. So this particular section is on the Section 9.1 Notes, and it is on translations. A transformation in general is a mapping of a geometric figure that results in a change in position, shape, or size of the figure. So that's kind of, again, the general term for the whole chapter. And now the specific one is a translation that we're doing this chapter, or this section. The pre-image is the original figure. Okay, the one that comes first, kind of like the word prehistoric. That prefix pre means before. Okay, the image is the figure after it has been transformed. Okay, and it's going to be very important that you pay attention to what is the pre-image and what is the image. I'm going to give you some indications of how to tell that in a little bit, but that's going to be really important to pay attention to that. Always think of what's the original one, what's the one that came first, and what is the new one. So that will be important. Rigid motion is a transformation that keeps the same lengths and angle measurements. Okay, so another way you can think of that is, like I mentioned a minute ago, actually I want to say same. So same shape and same size. All right. So if we look at a couple examples, and we need to decide if they are rigid motion or not. So this first one, we can see the pre-image, the original one. We can see the new one, the image, and we have to decide if that's rigid motion or not. And again, if it is rigid motion, it's staying the same shape and the same size. On number one, they are staying the same shape, but not the same size. So we would say these are not an example of rigid motion. Okay. If you look at number two, you can see that that figure did stay the same shape and the same size. It just got flipped to a new location. So that is an example of rigid motion. And on number three, you can see the pre-image and the image are the same shape, same size. Again, it's just been flipped over and shifted to a new location, but it is considered rigid motion. Okay, from there, is telling us that a transformation is described with arrow notation. So we will often see an arrow that, okay, it's mapping from this figure to this figure, and that arrow shows that. The prime notation is like a little apostrophe. So that is going to be used to identify the image points, the new ones. Okay, so the original figure is not going to have the prime marks. The new one, the image, is going to have the prime marks. And we can see the example here. We see this original triangle JKQ, and we can see that they have become J prime, K prime, Q prime in their new location. And so you can see different ways you can refer to this of what's happening. You say K is the pre-image and K prime is the image. We can say triangle JKQ transforms, like a say that for that arrow, to triangle J prime, K prime, Q prime. Or we could say triangle JKQ maps onto triangle J prime, K prime, Q prime. Okay, so just different terminology. It means the same thing. On example 4, it says describe the transformation using arrow notation and prime notation. So if we do, just like we just saw with the triangles up right above, we can just say, again, the original one does not have the prime marks. I could call that E, F, G, H, and that maps onto E prime, F prime, G prime, H prime. Okay. On example 5, it says triangle SUP is a transformation of triangle NID, and it says name all corresponding sides and angles. So again, if they tell me that triangle SUP transforms to triangle NID, just like when we talked about congruent triangles, the order of those letters matters. It tells you what is corresponding to what. So first letter, we know angle S corresponds to angle N. We can see middle letter, U corresponds to I. And we can see last letter, P corresponds to D. Okay, we can also see first two letters, SU corresponds to first two letters, NI. Last two letters, UP corresponds to ID. And first and last, SP corresponds to ND. Okay, and I can put the line segment symbols on all those. Okay, last part of this page says a translation is one type of transformation that slides a figure. So you could say slides or shifts, either way. And it's notated with a capital T. Okay, so from there, each type of transformation is going to have a capital letter or capital or lowercase letter that kind of is an abbreviation for what we're going to do to that figure. All right, so we look at example 6. I actually want you to make one little adjustment here that I forgot to make, I believe, before I made your copies, is that I want this translation to be -2, -5. Instead of -2, +5, because that's going to take us off the graph, and I want it to fit on the graph. I need to make that adjustment. So in this particular case, the capital T stands for translation. So now I'm going to shift all of these points. The thing in the brackets is telling us how much we're going to shift it in what direction. So sometimes it's helpful for people to label that as X and Y because it helps you remember that, okay, that first number is telling me how much I'm going to shift it in the X direction. Positive would be to the right, negative would be to the left. So this is going to be to the left 2. Second number represents how much I'm going to go in the Y direction, how much up or down. And so since it's -5, I'm going to go down 5. And then the triangle RQP is telling me what is actually getting shifted. So it's every letter, R, Q, and P. So if I take every letter and I go, again, this is telling me to go left 2 and down 5. So I need to do that for each letter and graph my new points, label them with, R prime, Q prime, and P prime, and then I can connect the dots to make my new triangle. So R is going to go left 2, down 5. 1, 2, 3, 4, 5 to right here. Go R prime. And then Q, left 2, down 5. 1, 2, 3, 4, 5. And there's my Q prime. And my P, left 2, down 5. 1, 2, 3, 4, 5. Okay, so there's my new triangle. And so we're often going to say what our new ordered pairs are. So if I go and say, okay, well, my new R is now at -3, -2. And my new Q is at 1, -2. And my new P is at 0, -4. Just make sure anytime you're naming ordered pair, you're naming the X first and then the Y. And that's it for that one. So not too bad. One thing I wanted to mention is, with the graphing, if the graph is there, then you do need to draw the new figure. You could do a problem like this without actually graphing it. You could just take the original ordered pair and then subtract 2 from the X portion and subtract 5 from the Y portion. So you can do it without graphing if needed, but a lot of people prefer just to do it with the graphing, especially if a graph is given to you. Okay, on number 7, it's saying to translate triangle ABC. And it's telling us here to, in the X direction, to go +1. So that's telling us to go right 1. And Y -2 is telling us to go down 2. So sometimes it just helps to kind of show what you're going to do to each point. And then we can actually take care of that. So I can go A, and I'm going right 1 and down 2. So here's my new A. My new B, right 1 down 2. Here's my new B. And my new C, right 1 down 2 is right here. Okay, sometimes they may overlap each other, and that's okay. And just to show you how this could work with the ordered pairs, again, if you didn't want to graph it, well, if the graph is there, you need to graph it. But if sometimes they might ask you a multiple choice question, there's no graph given, you could draw a graph yourself, or you can do it without. So I just wanted to show you how that would work. If A is at the point -2, 2, and I know that I'm needing to shift this point right 1 down 2, then that means I would go +1 to this value and -2 to the Y value. So then that means that my new A is going to be, my A prime is going to be at -1. -2 plus 1 is -1. And then 2 plus -2 is 0. So I know my new A value should be at -1, 0. And that's what I see over here that actually ended up happening. Okay. My new B is at 2, -1. And my new C is at 1, -3. All right, and last little bit down here, if you look at example 8, it says write the rule for the translation. So again, be really careful on these, that you're paying attention to what's the image and what's the pre-image. So again, the pre-image is the thing that comes first. So pick a point. I can say, okay, well, this is the pre-image. It is the original one. And find the ordered pair. This is at if you don't want to have to count the spaces, you can go -3, 4. That's helpful to you. And then, find the image of that. It's going to have the prime. So there's my P prime. That is at the point 5, 2. Okay. And if I want to go from the pre-image to the image, I would be going this direction. And if I want to know how much that is, I can either count the spaces, or I can think about from -3 to 5, how far is that? And it's 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we can see from there, I'm going down 2. Okay. And it's supposed to be an 8. It doesn't look like an 8. Okay, so that's what goes in here. +8, -2. And again, they're having me write the rule. That's the translation rule, 8, -2, for this particular figure. And if I check from S to S prime, or Q to Q prime, or R to R prime, I should get 8, -2 for all of those. I'm just saying how much is changing in the horizontal direction and how much is changing in the vertical direction. And just make sure you're going from the pre-image to the image with the prime marks. You don't want to go backwards. All right, that is it for section 9.1. You can let me know if you have any questions. Thanks.